Morning, 8th grade. Today what we're going to do is we're going to learn scientific notation. Cool thing about this is that it makes your life easier. So today's date, 8/29, scientific notation. We will practice this today and tomorrow. And I am actually on page, sorry about that, 9 and 10. And it looks like, see, even mistakes happen. 7 and 8, I made a mistake, but that's okay. All right, so page 9 and 10, we're going to do scientific notation. And what I'm going to do, if you notice you were given a green foldable, we're going to put it sideways. And for all of you artists out there, you can make your titles however you like, add color, take pride in your journal. Okay, so we're going to do both. Scientific notation obviously came, we commonly think of in science, for example, planets. They are millions of light years away. And we don't want to write those numbers that are so big. I mean, they probably have 36 zeros after the number. And so they've come up with, it's a way to express large numbers or the opposite, small numbers, for example, the size of a cell, okay, into numbers that are easier to work with, okay? So today, what you want to do is go ahead and cut this out, and you notice, just cut it right there, all right? Go ahead, if you want to glue it down, you can glue it down now. I'm going to go ahead, and I just put 4 small dots, and I use a little bit of the tip. Yes, we're already in 7th and 8th grade, or 8th grade. And we still put too much glue. All right, so what we're going to do today, at the top, I can. More of, I will, right? Because you haven't learned it yet. We're going to convert numbers from standard, notation to scientific notation and from scientific, you know where I'm going, scientific notation to standard. And you can pretty much figure that one out. The scientific is the abbreviated version, and the standard is the ridiculous number that we don't want to work with, those real long numbers, right? All right, so go ahead and let's take some notes. So first we're going to work with standard to scientific. This is the abbreviated, kind of a word, okay? So we're taking those yucky numbers and we're making it into numbers that are easier to work with. Yeah, I shouldn't have glued that in. All right, so positive exponents, you move the decimal to the right. Okay, negative exponent, you move the decimal to the left. Think of a number line, right? As you move it to the right, your number is going to get bigger, isn't it? And that's what a positive exponent does. A negative exponent, and I'm going to show you why. So let's look at right here. Turn it on the other side. And what I want you to do is put a kind of a light bulb. Maybe not. Like an idea, right? What is 10 to the 4th? That means 10 times 10 times 10 times 10, right? And that equals, that's right, you're going to have 1 and 4 zeros. Okay, 10,000. What is 10 to the 3rd? 10. I'm going to change that to a dot. That's right, you're going to have 3 zeros. Now 10 squared, and look, if you notice that my exponents are getting smaller here, aren't they? So a positive exponent, look at where the decimal is, right here. So it's a large value. 10 times 10 100. All right, what do you think 10 to the 1 is going to be? That's right, 10. Now what if we keep on going down? Okay, so 4, 3, 2, 1. How about 10 to the 0? You're right. It's, what is it? It's 1. I know some of you are like, huh? So that one's a tricky one. And if you notice the trend, it's dropping a 0, which is why 10 to the 0 is 1. Now let's look at it as 10 to the negative 1. We're actually dividing by 10, aren't we? That's right. 1/10 or 0.1. If you notice, the decimal place is moving and it's getting smaller, isn't it? What about 10 to the negative 2? 0.01. So really, all the powers do is they're working with the powers of 10. Okay? So smaller numbers with a negative exponent, and your positives are going to be values that are not the opposite. They're going to be larger numbers. Okay. So let's look at an example. In scientific notation, okay? Actually, they're doing the opposite. That shouldn't have happened. Yeah, because this is standard to scientific. Yeah. Anyway, I'm not sure why they did it. This is scientific, because this is scientific notation, to standard. And this is standard to scientific. And we're going to go through those examples. I'm sorry about that. Hoping it wasn't even on there, sorry. Okay, whenever you have scientific notation, you will always have only one number. You always have to have that number in the ones place and a decimal. And this number right here can be longer. It can be 4 numbers, it can be 3 numbers, and I'll show you why. In standard, it just looks like there's no powers of 10, okay? So what I want to do is I want to start over here. So what you do, actually, let's go ahead. I apologize. This was it was worded backwards, and anyway. So when we move the decimal to make numbers in the ones place greater than or equal to, but less than 10. Okay? So in other words, there's always going to be just one number there. Okay? All right, I want to start here. Now, when you have the decimal, if you didn't see a decimal, it's always to the right. What I need to do is follow that rule. I need to get, so I'm going to go over 1, 2, 3, 4, 5, 6, 7, and I'm going to stop. So what that means is I moved 7 spots, right? In other words, I'm going to, yeah, it's multiples of 10, okay? So 10 to the 7 power. Oh, sorry. And then my number is going to be in the ones place. I add a decimal, and I write the following numbers. All right? So whenever you have a positive exponent, your actual standard notation should be a large value, okay? The opposite is when I have a small value, okay? Now I'm going to move the decimal, but remember, I always have to get where I want it to look like this, okay? So my goal is where I have a number between 1 and 10, and I need to get the decimal here, okay? So what we're going to do is we're going to go 1, 2, 3, 4, 5, 6, okay? So that means that I'm going to multiply it times 10, and I moved it 6 places. The value of my original number was small, so it's a negative exponent, okay? Now, this part, here's my number, Here's my decimal. I could put a 0 here, but in this case, I didn't have anything else. So in actuality, it's 2. If I had a number here, I would put it right here. Okay? All right, let's look at the opposite. So when we have scientific notation, okay, I have a negative exponent. So that means that my number is going to be what? Small. Okay? So I have 1, 3, 5, and I'm not going to put the decimal, okay, when you're converting it back. So you start here, but you notice, that's right. Do I need to go to the left or do I need to go to the right? 10 to the negative 4, I'm going to make that number smaller if my decimal is to the left, okay? So I'm going to count 4 times. So 1, 2, 3, and 4, and I'm going to set it and forget it. But I need to add zeros. This one is not, I'm not going to add a 0 here, so be careful when you do that. I'm going to add a 0 here, a 0 here, and a 0 here. This is my number in standard form, okay? If you notice, when you have negative exponents and you're converting it back, your zeros are always 1 less than the power, the actual exponent. All right, let's look at the next one. So I know that my number is going to get bigger. Okay, so what we need to do is, I'm going to still keep that value of the negative. Okay, I'm going to write the number without the decimal because I'm wanting to move that decimal, right? So if you notice, am I going to go to the left or am I going to go to the right? I'm going to go to the right because I'm going to make the number bigger. Well, it's not really bigger, but anyway. But the whole idea, if I didn't have that negative, it would look like a larger value, okay? So what I'm going to do is I'm going to move the decimal place. I'm going to go 1, 2, 3, 4, 5, and 6. I'm going to set it and forget it and add the zeros. The tricky part about this is, yes, the zeros, it gets kind of tricky, so I would give yourself some space. Don't do little things like that and then cram in a bunch of zeros. You're going to end up messing up. Okay? All right, so what does that look like? Let's practice a little bit. All right, what you have, and always refer to what we did here, okay? So on this, I'm running out of time. I want you to practice on the first part. You are going to use the left side, okay? So the first 6. Then the bottom 6, you're going to actually use the right and follow the same thing. And it's just practicing, getting used to moving the decimal is all we're doing. On the back, it's kind of like a scavenger hunt. I want you to use your computers, and what you're going to do is you're going to find the standard, the regular number. You're going to research, you're going to find the elevation of Mount Everest. Is everybody going to have the same number? No. Okay, sometimes you might find some information, so it's just a guesstimate. I want you to find those big numbers, have a little fun, maybe with a friend, look up the size of a proton. You can even ask Mr. Gibson. So anyway, this should be fun, and then change them to scientific notations. But I only want you to do I'm sorry. You can only do 3, and that's your choice. Okay? Yep. See you tomorrow.